I'm kind of floundering here, but that's okay. I made the notes here. Nope. We were still working on this one. Okay. We were still working on this one here, but I want to delete these guys. So close.
Oh. Sorry.
Was it just close?
Yeah.
We got the best.
Okay. Yeah.
What was the best mark?
Just missing one mark, I want to say.
Just missing one mark?
Mm-hmm. Silly mistakes, too.
Yeah, I think
okay, let's see here. So I'm gonna add a page. I should probably not have started the recording. Oh well, you'll survive.
Get the highest mark? Get the highest mark? 5% or 8509? Go ahead. Yes.
So what I want to do, I want to keep all of next week for final exam review. And so what we can do then is bring questions from the test and we'll go through them. Okay, so bring test questions. Yeah. To go through together. What you'll notice is the final exam practice is going to be a mashup of test 1, test 2, and just a little bit of this new stuff. And so you'll have seen a lot of these questions. There's a lot of overlap in each test, right? So I kind of whittle it down to some bare bones and then, but still test the same concepts. Okay, so you'll have seen all of them before. And if there are any types of questions that you really, really want to do on the final, then we can talk about that next week and you can kind of let me know what you want. I'll take requests. So tests are marked. Guess I should have written that somewhere. I'm really pleased with how it went. I am a generous marker, but yeah, like I said, I was kind of worried because everyone seemed so down in the dumps during the test. And so, but I'm like, you guys are doing fine. What's wrong? Due for review on Thursday. Well, here we are. It felt like ages away, but here we are on Thursday. I'm going to bring this up here. We're in section 5.1, circles, continued. We don't do a lot of trig in this course, even though Frank kept asking me earlier in the term, have you done trig yet?
Once?
Oh. But maybe he's just curious. Okay, let's see here. Find the y-intercepts. Oh, whoa. Let's take it back a little bit, maybe. What does this thing look like? This is a circle, right? And I think there was maybe, just maybe, some formulas that we want. Maybe this one. Copy. Oh. The equation of a circle centered at the point HK, which we've seen before, right? With the vertex, but the context is different. So it's the center now with a radius R, can be written as x minus h squared plus y minus k squared plus is equal to r squared. So here, if we map our x minus h squared to y minus k squared is equal to r squared, right? This we can replace with x minus h squared plus y minus k squared is equal to r squared. From this, I can see that h is what? H must be -1, right? Because it's x plus 1. And so h must be -1. K must be 2. So now I know where this thing is centered. And the radius, well, you can take the square root, and then you can't have a negative radius, and so the radius is 3. Now we can draw this thing. Why do we want to draw it? We want to find the y-intercepts. Okay. And so the y-intercept, let's map this thing out. Just a quick sketch, I think. -1, 2, -1 is over here, and let's just do 2 here. Just a quick sketch. And a radius of 3. Let's just do a circle and see what happens. That might be bad. We'll see. But what do we want to find? We want to find these points, right? Just kind of visualizing it. I am trying, probably not successfully because I am a little bit sleepy. But we want to find where it crosses. Oops. I wanted pink here. The y-intercepts, right? That's why we have 2 intercepts. So how are we going to do that? Well, first, this is where x is 0, right? And so the y-intercept is where x is equal to 0. So what can we do? Well, I have the equation. And so I could plug in x is equal to 0 here and solve for y, which is what I want to do. Okay. And so we've got our, try to keep it on, x plus 1 squared plus y minus 2 squared is equal to 9. If I let x be 0, 0 plus 1 squared plus y minus 2 squared is equal to 9. 1 squared is 1. which I can subtract from both sides. And so then I'm left with y minus 2 squared is equal to 8. 9 minus 1. Now what can I do? I can take the square root. As long as you remember that you get a plus minus, that plus minus is going to be important, right? Because that's the only way that we're going to get both of these points. If you forget it, you would only find one of the points, probably this one. That's only half the circle. So you get y minus 2 is the square root plus minus of 8. And I'll highlight the plus minus in a subtle yellow. But from here, I can add 2 to both sides. And so I get y is, and if you want, right, a plus b is the same thing as b plus a. So it might be cleaner to just write, because I'm adding 2 to both sides here, right? It might be cleaner to do 2 plus minus root 8. But if you want to, you could write y is the plus minus root 8, but make sure you kind of cap your root so it doesn't look like you're taking the square root of the plus 2. But I just think it's a little bit cleaner with the 2 plus minus root 8. 2 plus minus root 8 is just a number. What is it? What are they, I should say? 2, I'll do minus root 8 first, because that's going to be the lower end. Negative 0.828427, blah, blah, blah. And then 2 plus root 8. 8.28427, blah, blah, blah. Even though I did kind of a weird sketch here, not that great, right? Those look like reasonable answers. Right? We can check with Desmos if you want. And I know you want. Let's see here. You can plug it in. X plus 1 squared, just the way you see it, plus y minus 2, right? Squared is equal to 9. Ta-da! And then when I click the intercepts, we did it. Nice. I'll add page here. I think this is a way of introducing the unit circle, because it's been a long time, but I don't remember talking about the unit circle yet. Maybe we did, maybe we didn't. But the unit circle has a radius of 1. That's all. And I'll have to confirm, but I'm pretty sure it's also centered at 0, 0. But this one I'm kind of, I don't know if that's necessarily true. Emily, to confirm if this is always true or always the case. Off the top of my head, I think so. I would say so, but or is it just that the radius is 1? Either way, we're given the equation, and in this case, it is centered at 0, 0. Why? Because I have x minus 0 squared plus y minus 0 squared, and then is equal to 1, which means the radius is 1 and it's centered at 0, 0. like I said, I'm pretty confident, but maybe too confident. We want to find x when y is equal to 1/2. So again, if we sketch this graph, right, a circle centered at 0, 0 with a radius of 1, if y is 1/2, since I know you'll be curious. Yeah. Cool. If y is 1/2, whoops, did not mean to move that little guy there. Then if the radius is 1, then y equals 1/2 would have to be here somewhere. Right? Oh, Emily, to confirm if this is always the case. And like I said, I'm pretty confident that it is, but I don't want to say that it's always the case if it's not true, if it's just the radius being 1. So I just want to confirm it, but I wrote it in pink, so I'm feeling pretty good about it. Watch, I have to backpedal. Okay. So what we want to find, right, are these points, these values of x. How can you check your work? Even before we start, we know those x values have to be within -1 and 1, right? Between 0 and 1, because the radius is 1 and it's centered on 0, 0. So we already have all this information, but now we want to figure out, okay, what are those x values when y is 1/2? This is the same question as the one we just did, right? I'm going to plug in y equals 1/2, and I'm going to solve for x. So I have x squared plus y squared is equal to 1, which means I have x squared plus 1/2 squared is equal to 1. 1/2 squared is 1/4. You can do it on your calculator. You get x squared plus 1/4 is equal to 1. Now, that means that x squared is 1 minus 1/4, which is 3/4. Or, no, that's okay. Your calculator is going to do that for you anyways. So now we're just left with x squared, but we know x is the plus minus the root of 3/4. So x is going to be root of 3/4 negative 0.866025 and positive 0.866025. Does it make sense that they're kind of mirror images of each other? It does, because it's centered at 0, 0, right? And so a circle is it's not lopsided, right? So they have to be the same, just the negative and the positive version. But also we see that they're within -1 and 1, and so everything kind of checks out. Okay? And you can check it in Desmos, but let's keep going. What if we have to find the intersection of x squared plus y squared is 16, and this is a line, right? F of x is 3 minus x. How are we going to do that? F of x, whenever you see f of x, you can just replace it with a y. Right? I find that that's going to be really helpful, right? f of x just says that, okay, this thing is going to take any value of x and it's going to return some y, but you can just write it as y. So now this is a line, right? Y equals mx plus b. I only have one x. And so this is a line with a y-intercept of 3 and a slope of -1. This is a line with slope equal to -1 and y-intercept equal to 3. We can sketch this thing out. How do I sketch the circle? When I just see x squared plus y squared in there, then I know it's centered at 0, 0, right? And so let's start with the circle. 0, 0. The radius, r squared is 16, so the radius is 4. So on my scale that I made up here, let's make this 4. Oops. So now I have a line with a y-intercept of 3. Let's put that, I don't know, halfway. Let's put it there. Better there. With a slope of -1, so we know it's going to look something like this. But how about I do it a little bit better? And what can I do? Well, I know this is at x equals 4. So how about I plug in x equals 4 into here and see what my y value would be. And then I have 2 points that I can connect to the lines. So if I put in x equals 4, right, so that would be kind of somewhere here. I should have butted it up against the circle, but whatever. If x is 4, 3 minus 4 is -1. So then that's somewhere down here. Maybe I'll move it over just a little bit. This is bothering me. It should be something like that. Because this is at 4. Sloppy all around here. Okay, there-ish. It's probably, that's a bad scale. Might help. On the final exam, which we're working towards, obviously, I'll give you a blank graph so that you don't have to worry about the scales and stuff. Oh, and I should say, make sure, because it's been a long marathon marking week, and so make sure that all the tallies in your test check out, because like I said, I do double check my adding in the table on the inside cover, but if you find any discrepancies, well, if they're in your favor, don't tell me. Although I'm always curious how many I mess up on. But if they're not in your favor, then obviously tell me. And don't worry, for the final exam, my husband is well trained and he goes through and he checks all of them for you because you can't see them, obviously. So don't worry, they will be checked thoroughly because it's important. All right. I can't be trusted for that kind of stuff. No, I can't. Y equals 3 minus x looks like that, right? Just like we expected, a negative slope, all right? So if you have 2 points on the line, you can draw the line. All right, so somewhere here and here, that's where we have the intersections. So those are the values that we want to find. That's not as easy as what we had before, right? But what can we do? I can plug in just like we did earlier. If y is equal to 1/2, I plugged it in and I was able to solve for x. What if I do the same thing here? If I plug in y is equal to 3 minus x into here, I can still solve for x. What's going to happen? I'm going to have an x squared and another x squared, right? Luckily, we know how to work with x squared. So x squared plus y squared is equal to 16. You could, in a very weird roundabout maneuver, solve this circle for y, but you'd get a plus minus root and plug it into here and then solve for x, but that seems like way more work than it needs to be. So I'm going to plug in x squared plus 3 minus x squared is equal to 16. All right. From here to here. Okay. Being very careful with that 3 minus x squared, because 3 minus x squared is 3 minus x times 3 minus x, right? And so I always have to do it nice and slow. You can do it quicker if you want, but x squared plus, and I'll do big brackets around in case a negative shows up, then I want to incorporate that. 3 times 3 is 9. Minus 3x minus 3x plus x squared is equal to 16. This doesn't affect anything, so now I can rewrite this. I can collect like terms, right? X squared plus x squared is 2x squared. So I get 2x squared minus 6x plus 9 is equal to 16. Oh, what a relief. Why? Because you can set this into a quadratic set equal to 0, right? By subtracting 16 from both sides. So here, now you have a quadratic, which we're always happy to see at this point because it makes it easier to solve for. So 2x squared minus 6x plus 9 minus 16. So 9 minus 16 is minus 7 is equal to 0. Have you guys figured out how to use the quadratic formula on your calculator yet?
Let's try.
Might be worth a Google. I still don't know.
When I Googled it, it was just like, it was just telling me to store ABC and then just keep punching those numbers in all the time. Like, I feel like that was really saving me any time now.
Yeah, that's
all.
I know it knows. You just plug in the coefficients and then it just tells you what the values are. It does do it. I've seen it. I saw it last year. But I guess, yeah. I'll have to ask Stefan how to do it. I was like, how did you do that? It's like, well, I read the manual. That's how I did it. Like, oh. There is, and I actually have I have some spare manuals for those ones. So, but it is online too. All right. X is negative b plus minus the square root of b squared minus 4ac over 2a. You don't have to memorize it. It's on your formula sheet. Although I nearly forgot to put it on your formula sheet. That would have been really bad. Negative 6 is 6 plus minus the root of negative 6 squared minus 4 times 2 times negative 7 divided by 2 times 2. 6 plus minus, now 36 minus 4 times -7. 4 times 7 is 28. 36, I want to say plus 28. And then the square root of 64 is 8 divided by 4. Hey, why is it glitching? So I get 6 minus 8 divided by 4. So x is -1/2. And x is 6 plus 8 divided by 4, which is 7/2. Or x is -0.5 and x is 3.5. Doesn't matter to me. Right? You can leave it in exact form. Might be easier at that point. But for visualizing, this makes more sense, right? Because this would be at x equals -0.5, which checks out and looks like it's going to be kind of close to the y-axis, right? What about this one? I expect it to be kind of close to 4. And it's at 3.5. Close enough. Okay. So, nice. Maybe I'll draw it here. I didn't want to draw it on our original one because that'd be confusing. So here, now we found that this is at -0.5 and this, I did a bad drawing, but is at 3.5. If you have the x values and you have the equation of the line, right? Because at the intersection, the line and the circle have to be the same, but it's easier to work with the line than the circle, in my opinion. And so what can you do? You could plug in those values of x and solve for y. Let's see here. The intersection is the point. So now, last step, we can now use these x values to solve for the y coordinate. So where x is equal to -0.5, y is 3 minus x. 3 minus -0.5 is 3.5. So then the coordinate here would be at -0.5 and 3.5. How about where x is 3.5, y is 3 minus 3.5. So then y is -0.5. So then this is at 3.5, -0.5. All right, just for fun, let's check it in Desmos. Where is it? We had x squared plus y squared is equal to 16. And then we had another line at 3 minus x. These are the values. Did I do something wrong? Where did I go wrong? Did I? this one here.
Answer inside the brackets is not.
Oh no.
6 plus minus square root of 92.
Sloppy, sloppy, sloppy. Okay, 6 squared minus 4 times 2 times -7. Oh no, why did I get a convenient value when it's not? All right, I'll do it in red. Too far gone. But my values were really nice.
They were. I think you should just keep them. Yeah.
Oh boy.
But still post decimal image. See if people can catch there.
You do the same thing, just with the not so nice numbers. How about I'll fix it later. But yeah, like you suggested. You know what? I will take you up on that.
See if people can spot there.
Hey, why isn't it screenshotting? No, I want these in here. Okay, good. Because it's the most important part of where I messed up here. Oh boy. So close too. Had it. Funny that I made it so easy. Usually if I mess something up, I make it way harder than it needs to be. But this time I made it more convenient.
Yeah.
I'll fix it, but now you know what values of X and Y you're going for at least. Remember how I told you to read this one and think about how you would solve it? All right, let's see here. An ant is heading toward a circular region of pancake batter. Uh-oh. The ant cannot breathe while walking through the batter. The batter has a radius of 4 centimeters. The ant is going to walk from a point 6 centimeters due north of the batter's center to a point 5 centimeters due west of the batter's center. The ant moves at 0.8 centimeters per second. How long will it have to hold its breath? Kind of an additional layer. And then I'll give you the graph, just like I promised. And just like I will on the final exam, when you have to solve one just like it, it will be an ant, and it will be pancake batter, and it will be exactly like this. It's going to be a multi-phase question, just like the dead body question. Can we make it a turkey for the final exam? Yeah. Dead body's so gruesome. We'll do a turkey, or maybe a cheesecake. Something festive. All right. So, how would you solve this? Before I use my graph, let's do a quick sketch here. Add a page. So I've got situation like this, and we want to first figure out where this ant is starting from, right? And then where it's going to end at. Okay? Now that's going to make a line. We just assume that ants just walk in a line. That's fair. And so it's going to walk from a point 6 centimeters due north of the batter's center. And so what I'm going to do is I'm going to just put the batter center at 0, 0, right? That's going to be the first step. And then if I use just 6 units here, 6 centimeters due north, or maybe I should use the lines here. That's where it's going to start from. And then it's walking to a point 5 centimeters due west. Never eat shredded wheat. Never eat shredded wheat. Huh? Or whatever your personal northeast. Do you guys have other ones?
Never entered Shrek's washroom.
Oh, that one's better actually.
Never eat soggy wieners.
Yeah.
Yeah.
I just go like
You just know them?
Hey, you just know them?
No,
Yeah. Yeah. Hot take. 5 centimeters due west. When we're due west, it's just exactly on the west line. And so let's put a 5 there, let's say. And so the ant is walking from here to here. I'll do an arrow like that. So if on this kind of makeshift graph, this is 4, why did I put 4? Because we had a radius of 4 for the pancake batter. And so now, okay, it has to cross at 2 points. It will, I'll force it to. There. Let's say this.
bring it to our stop next semester.
I know, right? Well, it's because it swings open. And then the hallway is so loud, which is weird because there's no one out there. Yeah. Air is so loud. So this ant is going to walk through this pancake batter, but for this is the danger zone, right? This length of batter trek, I guess, right? So here it has to hold its breath. We can find those intersections, right? We know how to find those intersections. We just practiced it. I made it easier than it needed to be, but we know the method, right? I've got a line, I've got a circle, I can find the intersections of the circle. Then what would I do? I need to find this distance, right? I need to find how far did it need to walk? We assume that the same speed applies, whether it's walking through pancake batter or just not, which doesn't really make sense, but that's okay. And so, right, once we find this distance, need to find this distance. Then we can figure out, okay, we know how fast the ant walks. And so then I can figure out how long it needs to hold its breath for. Uh-oh. Okay. So with the grid, let's map this out because now we have a plan, right? What's our plan? Step number 1, is, of course, draw the circle and the line. Step number 2 is going to be find the intersections. Find the intersections. If you have the intersections of something like this, how are you going to find this distance? Or maybe I'll do it over here. Find the distance. Nice. Because you have these coordinates, right? A squared, ABC, A squared plus B squared equals C squared. This projector. So you can solve for C. Right? A little bit of work. Oh my gosh. Once you have that distance, right, then C is some distance in centimeters. Right, once you've found it, multiply by the speed. So C is in centimeters times, and then I think, or I guess it's divide, 0.8 centimeters per second, divide. But you guys are usually better with working with units by now, right? Kind of canceling units. What do you need to do to cancel these? And so divide by the speed, which is in centimeters per second. How fractions work, if I divide, if I have a fraction over a fraction, I have centimeters over 1 times centimeters over seconds. But if I flip it, right, if I bring it upstairs, then I get seconds per centimeter. And that's how you cancel these centimeters. And then that's how long it needs to hold its breath for. So it incorporates a lot of skills that we've introduced in this section. And so that's why it is on the final exam. Okay. If at any point, I do suspect that you'll be comfortable drawing the circle and the line on the graph provided, right? And so that's a good start. That's worth marks, okay? If for some reason you can't find the intersections, okay, then just tell me, hey, I forgot how to find these intersections, right? But let's assume that they are, and then give me some reasonable values, right? Just pick some reasonable values from your graph that you gave me. And then you don't get marks for finding the intersection, of course, but then you can still find the distance. And then you can still find how long it needs to hold its breath for, right? Same thing, if you blank on how to find the distance, just tell me, hey, I can't remember how to find the distance. It's not coming to me. Let's say the distance is, and again, just pick something that looks reasonable, right? You have the scale, right? And so, so don't be bogged down by kind of, okay, I don't know how to do this, but I could keep going, right? I want to see that. If you know how to keep going, then show me. Okay. All right. We ready to tackle this one? So it is on the final exam. I cannot stress this enough. I'll change the starting location of the ant and maybe the end location of the ant. I'll change the speed and maybe the radius, but knowing how to tackle this problem is what's important. Okay. So now I'm ready to commit with this beautiful scale, because now I have 1, 2, 3, 4, 5, 6. Let's move our ant. Hey. 1, 2, 3, 4, 5, 6. She starts up here. Yes, it's a she. 1, 2, 3, 4. Okay. So she starts at 6, 0. And then she walks 2.5 centimeters due west. And so now I want to put a line 1, 2, 3, 4, 5. So this is at -5. Sorry, I did this weird. This is at 0, 6. Because I'm so worried I'm going to 1, 2, 3, 4, 5. Okay, good. So now we can draw the line, which is the path of the ant. Connect the two and use a straight edge. You always have paper in your exam, right? And so what I would do, or what I do is I just kind of take the remaining pages and just kind of fold them gently and use that as my straight line. You just want to have a nice straight line. So you don't need to have a ruler or anything. Right. Okay. Now, so this line has an equation. How can I find this equation of the line? I have 2 points on the line. To find equations of the line, which I guess I didn't put in as a step. Find the intersections involves a little bit more work. I'll call it 1B. Find the equation of the circle and the line. Find the equation, oops. Of the circle and line equations. Snuck that in there, 1B. Then you can find the intersections. So we can find the equation of the line. It passes through -5, 0 and 0, 6. And so now I can have the slope is y2 minus y1 over x2 minus x1. That's from chapter 1, right? And it's on your formula sheet. And so kind of incorporating those skills as well, right? y2, let's call it 6 minus 0 divided by x2 is 0 minus -5. I get a slope of 6 over 5. If I have a slope of 6 over 5 in y equals mx plus b, let's start there. Y equals 6 over 5x plus b. You can pick either one of those points because then you know those have to be on the line. And so I'm going to pick a convenient value, which for me in this case is going to be this -5, 0. Because then if x is 5 and this is dividing by 5, then it goes away, right? So then okay? But plug in any x, y coordinate that you know is on the line and then solve for b, right? At -5, 0. Let's see here. If x is -5, y is 0, 6/5 times -5 plus b. Solving for b, I get negative b if I float that over to the left-hand side. 0 minus b is -5 divided by 5 is -1, so -6. So then b must be 6. So then the equation of the line is y equals 6/5x plus 6. Oops. And we can draw it on Desmos just because now I'm kind of shaking in my boots. Did I do something weird again? So if I have 6/5 x plus 6, just want to make sure. Okay, so it does do what we told it to do. So that's good. All right. On to the next one. What's the next step? Well, we want to find the intersection of the circle, but let's draw the circle then. So the circle, and remember, we're using the origin as the center of the batter, and that's going to simplify things a lot, right? You don't want to pick a random spot. You want to use it as the center. So then we have a radius of 4. What color can I use here? Let's use green. 1, 2, 3, 4. 1, 2, 3, 4. So now I'm going to see if I can draw a circle here. And I want to make it beautiful. Whoa. Okay, there. This is a circle with radius 4. It's hard to see it, but we can zoom in here, right? That's the little stretch that she has to walk through the batter. So, but first we need the equation of the circle. Oops. I was using green. Find the equation of the circle. We know it's x minus h squared plus y minus k squared is equal to r squared. But we force the center to be at 0, 0, which is convenient. Force hk to be at 0, 0. So then x squared plus y squared is equal to r squared, which is 4 squared, which is 16. Okay. So now we have these equations, and our next goal is to find the intersections. Kind of plugging away at this thing. I'm expecting both my x values to be negative, right? And let's see here, and less than 4, right? Otherwise we did something weird. So find the intersections of y equals 6 over 5x plus 6 and x squared plus y squared is equal to 16. On its own, that's a question like the one we just did, right? It's a line and I plug that line in for into my circle for my y coordinate. And then I'm able to solve for x. And then once I have my x's, I can use, I think it's easier to use the line to find the value of y, but you could use the circle if you want. It's weird. So r is 4, I think. Yeah, the radius is 4. And so 4 squared is 16. Or is there a different 16? So if we have to find the intersections of this thing, I'd say the easiest way to do that is to plug in this value in place of y. So I get x squared plus 6 over 5x plus 6 squared is equal to 16. And I'll just make a note here, r is 4. Okay. Once I square 6 over 5x plus 6 squared is kind of nasty, but let's have a look. We can still work it though. X squared plus, just got to be careful, x over 5x plus 6 times x over 5x plus 6. X over 5 squared should be 36 over 25. Does that? Probably not. Does go to 1.44, which might be easier to work with. I don't usually kind of cut the fractions, but 6 over 5 is just 1.2. So if you prefer to just work with 1.2, then maybe that's nicer, right? And I would recommend maybe switching from fractions to decimals because a lot of people don't like fractions. It's normal. So 1.2 times 1.2, let's do that, is 1.44. So x squared, I'll make a note here. Working with decimals might be easier. And 6 over 5 is 1.2. So then I get 1.44 x squared, right? 6 over 5 times 6 over 5 is 1.2 times 1.2, which is 1.44 x squared. And then I have math. 6 times 1.2 is plus 7.2x. 6 times 6 over 5x, or 6 times 1.2x, is again 7.2x. And then plus 6 times 6, 36, is equal to 16. I can collect like terms and simplify. I have 1x squared plus 1.44x squared. It's all addition, so I don't need those big brackets. It's only if we have negative or a subtraction out here that it would make a mess, but we won't. So you're safe if you don't want to write those. But 2.44x squared. 7.2 plus 7.2 is 14.4x. plus 36 is equal to 16. What's nice is, right, again, we've got a quadratic. You have to set it equal to 0 to use the quadratic formula. So 2.44 x squared plus 14.4 x plus 36 minus 16 plus 20 is equal to 0. All right, Emily, be super careful now. I'm still amazed that I made the question easier, not harder, by messing it up. But here, x is negative b plus minus the square root of b squared minus 4ac over 2a. So x is negative 14.4 plus minus the square root of 14.4 squared minus 4 times 2.44 times 20 divided by 2 times 2.44. Definitely not going to be nice, but let's see what we got here. Minus 4 times 2.44 times 20. I'll jot it down. Plus minus the root of 12.16 divided by 2 times 2.44 divided by 4.88. I'm going to add a page. Okay. Let's do the root of 12.16. No, let's just do it. Negative 14.4 minus the root of 12.16 divided by 4.88. X is negative 3.665393269. And I am going to use Desmos to check it before I commit. Negative 14.4 plus the root of 12.16 divided by 4.88. Negative 2.236246075. They look reasonable for the values of x, right? But let's go back to our circle. X squared plus y squared is 16. So I'm going to jot that on here. X squared plus y squared is 16. Oh, phew. Those are the x coordinates. Looks good. I think I didn't actually pay too much attention, actually. Just looked good. Oh, I've got them both on the screen here, but you can't see. Negative 2.23. Negative. Okay, nice. All right. What I'm going to do is I'm going to grab just a zoomed in version of this so we can look at it. Yeah. Of course, this one here is the negative 3.665, or x is negative 3.665. I can stop there, right? I don't need you to carry all those decimal places, right? I kind of lose interest after the 5, right? 3, 9 would round to 4, but it still wouldn't take me anywhere. And so here I would say use 3 decimal places, and let's just confirm, because you want to have them matchy-matchy. And so here, again, after 3 decimal places, I kind of run out of steam and I stop caring. And so here, 3 decimal places is good. So then, I have here, x is negative 2.236. I need to figure out what these y values are, right? There's a y value here and a y value here. This is at x is negative 3.665. And so if y is 6 over 5x plus 6, let's start there. Then y is 6 over 5 times negative 3.665 plus 6. You can use the rounded value, 6 over 5, which is also 1.2 if you prefer. But I think I had it written as 6 over 5, but it doesn't matter. Negative 3.665 plus 6. I get a y of 1.602. You can, but it's harder. But you can, for sure. Because the intersections are where they're the same. So they should both give you the same value.
Yeah, but the number is not very accurate.
Yeah, that's true. Yeah, so, but yeah, as long as you remember that you rounded, it's fine. Okay, so then here, this y, again, 6 over 5x plus 6 at x equals negative 2.336 plus 6. Let's see here. Times negative 2.336 plus 6. I get 1968, but with a rounded value. Let's just stick to 3 decimal places at this point. And so I get 197, rounding properly. Good. Now I have the intersections. On to the next step, which is finding that distance. Right? And so now find the distance between, let's see, negative 3.665 and the y value there was 1.602. And what's this? Negative 2.236. Hey, it looks like I used a 3 here. Did I do that bad? 1.2 times negative 2.236. I think so. But I caught it, so I get to just change it incognito here. 3.31768, but I'll round it. keep it 3 decimal places. Does that look better? And is that what you guys got? I'll check Desmos. Let's see, can I do that split screen thing? I can. Okay, 1.602 to 3 decimal places and 3.31. Awesome. Good enough. So it's confirmed. This question on its own, reasonable enough, right? Find the distance between 2 points. And so that's the thing about this question is all the little components break down to pretty reasonable questions, right? It's just when we have to link them all up, it's hard. So we've got triangle. Ah, close enough. This was at negative 2.236 and 3.317. And this little guy is at negative 3.665 and 1.602. We can call this distance A and this distance B and this distance C. How are you going to find the distance of A? The distance of A is the distance on the x-axis. So A is the distance between negative 2.236 and negative 3.665, right? For a moment, if you want to, you could drop the negative, right? But as long as you remember that the distance is positive, but in the negative direction, then it's okay. And once you square it, it actually doesn't matter, right? A squared plus B squared equals C squared. And so it is going to be a negative distance, I guess, unless we do x2. Negative 2.236. Last year, when I was going to do this question in class, the projector was broken. So I had to do it all on the board, which is just terrible. A memorable nightmare. I was like, so what do we do now? Because there's like a lot of copying and pasting and using Desmos that we're doing here. And so couldn't do any of that. Negative 2.236 plus 3.665. A is 1.429. How about B? 3.317 minus 1.602. Just always make sure that it checks out. 1.715 looks like a reasonable distance to me. So now A squared plus B squared equals C squared. A squared is 1.429 squared plus B 1.715 squared is C squared, which is what I'm trying to find. One day we'll find it. Remember when you guys were like, oh yeah, but I've seen people working through, they showed me questions and they were like, pages upon pages of work. And I said, we'll get there. And here we are. Just pages upon pages. But
remember doing this and having to draw the graphs on graph paper on the side all the time on top of it. It sucked.
So then C is, let's start with the root of 1.429 squared plus 1.715 squared. $1.429 squared. But isn't it going to feel so good when you do tackle this one? Because you will. It's the root of 4.983266. Two, three, two, three, two, three. Or just 2.232, let's say. Sticking with the 3 decimal places. Therefore, the ant must hold its breath for 2.232 centimeters. Right? That's the distance. But the question was how long? Right? And so finally, at a speed of, I want to say 0.8, but let's just, we don't want to flub it on the last bit here. 0.8 centimeters per second. How long will it have to hold its breath? Pages upon pages. So 2.232 centimeters at a speed of 0.8 centimeters per second, we get 2.232 centimeters divided by 0.8 centimeters per second, which is the same as 2.232 centimeters times 8 over 1 becomes 1 over 0.8, sorry, 0.8 centimeter, 1 second, centimeter. Now these units cancel, and I get 2.232 divided by 0.8, 2.79 seconds. But for an ant, I mean, that's got to be a long time. Maybe. Ta-da! Did it. How about I move this? Put it on the same page here, but I'll just do like this. Rough work to start. Kind of you had to be there. I don't know why I did a stock market crash there. Works its way back up. Or maybe I shouldn't, maybe because I had a graph there, I'll just delete that page there. tell me why this question, or think about, I should say, because I don't get you to tell me stuff. Think about why this question is exactly the same as the last one, with the exception of the last step, which is not needed in this case. So in a town, Main Street runs east to west, and Meridian Road runs north to south, right? So we've got Main Street, we've got Meridian, right? Kind of mapping out the problem. A pizza store is located on Main Street, should say, 2 miles east of the intersection of Main and Meridian. If the store advertises that it delivers within a 4-mile radius, even the radius is the same, how much of Meridian do they deliver to you? Huh. Okay. Kind of map this out in your brain maybe, or do a quick sketch here. Never eat shredded wheat or soggy wieners. Or never enter Shrek's washroom, which I think is very funny. So here, Main Street runs east to west, or the other way around. And so that makes this Main Street. And Meridian Road runs north to south. And so that makes this Meridian Road. We've got kind of a naturally occurring center now, right, for the graph. So the first part is kind of just picking apart the information, mapping it out, or doing a quick sketch first, and then you can commit to the graph that I give you. A pizza store is located on Main Street. I'll add that in here. On Main Street, 2 miles east of the intersection of Main and Meridian. So here we have the intersection of Main and Meridian, right? And so 2 miles east. This is going to be the center of the circle, right? Because then it goes on to say that they claim that, so they advertise that it delivers within a 4-mile radius. So now if I kind of do a quick sketch of this thing, and we'll have the graph, right? But this should be centered at 2, 0. Oops, centered at 2, 0, right? Yeah, here. Yeah. So now we're not centered at 0, 0. We're centered at 2, 0. And we made a radius of 4. And we want to figure out how much of Meridian Road do they deliver to? So now, right, we have this radius of 4. And we can see, okay, there are some, looks like we're going to have some intersections, and we're going to jot this down properly, right? But it looks like we're going to have some intersections here. And what do we want to find? We want to find this distance, right? How much of that Meridian Road would they deliver to? Probably not very much in a 4-mile radius, right? It's going to be less than what? Definitely less than 8 miles, right? Because that would be this distance, right? a radius of 4. So you can kind of check your work that way. It should be less than 8, but positive. Right? And so this question is, in my opinion, the same as the other question. I know it's, not really, but you've got a line and you've got a circle and you want to find the intersections and then use those intersections. So in my mind, these two are the same. How are they different? The equation for the circle is more complicated, right? Because it's no longer centered at 0, 0. But the equation for the line is a lot simpler, right? Because if this is 0, 0, right, then what is this line? What is Meridian Road? Meridian Road is at x equals 0. So that's an easier line with a tougher circle, but the idea stays the same. Okay. We were going to do 2 more sections, and before I commit to anything, I'm going to check with Allison and Sydney and see if we can just do review next week instead, or if I have to do it. So stay tuned. But what I want you to do is try this question on your own, and then we'll do it next week together, run through it. Okay. But it is going to be really important that you try it on your own. So we do have time, and I encourage you to try it now. But I know you've got places to be, so it's okay. But definitely try it so that when we do it together, you know where your thought process was. Okay? So give it a go, but I'll stop this recording, and I sort of release you, sort of don't. But I hope you have a great weekend.